To me, psychology is a hugely important discipline. The brain is so mysterious, and so it seems so distant. But at the same time, it's responsible for the full transparency of everyday life. The brain is literally what makes everything obvious and familiar. I would be the last person on earth to suggest that reality renders psychology in its own right. I am fond of saying that I have learned much more from psychology than I have from neuroscience. To me, psychology is a hugely important discipline. And one thing that warms in my heart is that ways of investigating behavior that have been native to cognitive psychology since its, dawn in the 60s, they're starting to become interesting to AI researchers for a variety of reasons. And that's been exciting for me to see. One thing that impressed me most when I was at that stage in my education was neuropsychology, analyzing the behavior of populations who had brain damage of different kinds, and trying to understand what the specific deficits were that arose from a lesion in a particular part of the brain. And the kind of experimentation that was done and that's still being done to get answers in that context was so creative, and it was so deliberate. It was good science. An experiment answered one question but raised another, and somebody would do an experiment that answered that question, and you really felt like you were narrowing in on some kind of approximate understanding of what this part of the brain was for. Very detailed neuropsychological studies of language function, looking at production and reception and the relationship between visual function, reading, and auditory and semantic. And there were these and still are these beautiful models that came out of that kind of research that really made you feel like you understood something that you hadn't understood before about how language processing is organized in the brain. But having said all that, I think I agree with you that the cost of doing highly controlled experiments is that you, by construction, miss out on the richness and complexity of the real world. One thing so I was drawn into science by what in those days was called connectionism, which is of course what we now call deep learning. And at that point in history, neural networks were primarily being used in order to model human cognition. They weren't yet really useful for industrial applications. Neural networks were very concretely the thing that drew me into science. I actually was quite interested in surgery. I was interested in surgery and psychiatry, and I thought I must be the only person on the planet who was torn between those two fields. And I said exactly that to my advisor in medical school, and he conjectured that the reason that people develop these two interests is that both fields are about going beneath the surface and kind of getting into the kind of secret. Yeah. Maybe you understand this as someone who was interested in psychoanalysis at an early stage. There's a cliche phrase that people use now on, like an NPR, the secret life of blankety blank, right? Yeah. And that was part of the thrill of surgery. It was seeing, the secret activity that's inside everybody's abdomen and thorax. My kind of advisor in that rotation asked me what I was interested in, and I said, well, maybe psychiatry. He said, why? And I said, well, I've always been interested in how the brain works. I'm pretty sure that nobody's doing scientific research that addresses my interests, which are, I didn't have a word for it then, but I would have said about cognition. What had always fascinated me, even when I was a pretty young kid, I think, was the paradox that lies in the fact that the brain is so mysterious, and so it seems so distant, but at the same time, it's responsible for the full transparency of everyday life. The brain is literally what makes everything obvious and familiar. And there's always one in the room with you. I used to teach a cognitive neuroscience course, and the very last thing I would say to the students was, when people think of scientific inspiration, the metaphor is often, well, look to the stars. The stars will inspire you to wonder at the universe and think about your place in it and how things work. And I'm all for looking at the stars, but I've always been much more inspired, and kind of my sense of wonder comes from not from the distant, mysterious stars, but from the extremely intimately close brain.
Yeah.
There's something just endlessly fascinating to me about that. I often find discussions of artificial intelligence to be disappointingly narrow. Speaking as someone who has always had an interest in art, there are many layers to full bore human experience, and in some ways it's not enough to say, oh well, don't worry, we're talking about cognition, but we'll add emotion.
Yeah.
There's an incredible scope to what humans go through in every moment. And yes, so that's part of what fascinates me, is that our brains are producing that. But at the same time, it's so mysterious to us how we literally, our brains are literally in our heads producing this experience, and yet it's so mysterious to us, and the scientific challenge of getting at the actual explanation for that is so overwhelming. That's just, I don't know, that certain people have fixations on particular questions, and that's just always been mine. But at the same time, one thing that I found really exciting about that first wave of deep learning models in cognition was the fact that the people who were building these models were focused on the richness and complexity of human cognition. So an early debate in cognitive science, which I sort of witnessed as a grad student, was about something that sounds very dry, which is the formation of the past tense. But there were these two camps. One said, well, the mind encodes certain rules, and it also has a list of exceptions, because of course, the rule is add ed, but that's not always what you do, so you have to have a list of exceptions. And then there were the connectionists who, evolved into the deep learning people, who said, well, if you look carefully at the data, if you look at corpora, like language corpora, it turns out to be very rich, because yes, there are most verbs that, and you just tack on ed, and then there are exceptions, but there are rules that, the exceptions aren't just random. There are certain clues to which verbs should be exceptional, and then there are also exceptions to the exceptions. And there was a word that was kind of deployed in order to capture this, which was quasi-regular. In other words, there are rules, but it's messy, and there's structure even among the exceptions, and it would be, you could try to write down this structure in some sort of closed form, but really, the right way to understand how the brain is handling all this, and by the way, producing all of this, is to build a deep neural network and train it on this data and see how it ends up representing all of this richness.